welcome to this explainer. Look, today we're tackling what is honestly the ultimate final boss of data science, extracting clean data from chaotic, unstructured PDFs. If you've ever spent hours manually copy-pasting numbers from dense research papers, only to completely lose your mind over weird formatting, you know exactly what a nightmare this is.
So it begs the question, right? How do we actually turn these messy PDFs into perfectly structured JSON? I mean, the messy PDF is basically the main antagonist of our data evolution story here. It hides critical data across page breaks, it buries numbers in complex, visually confusing tables, and it masks key findings behind massive walls of text. We need a reliable way to defeat it. Well, enter the hero of our explainer today, Lift. It's this incredible 9 billion parameter vision model built by Data Lab, and I just gotta hit you with a massive stat right out of the gate, 90.2%. That is Lift's field accuracy on Data Lab's benchmark for document extraction. To put that into perspective, it completely crushes legacy systems like Azure, which sits around an 83.4% accuracy rate on those exact same tasks. Okay, let's dive right into this and see exactly why Lyft is outperforming the competition. Traditionally, we've relied on simple text parsing and open-ended summarization, but that is incredibly error-prone, and honestly, it often hallucinates data. The real game changer here is schema-guided retrieval. This gives us controlled, strictly disambiguated fields, precision over approximation, every single time. Let's formally define what this actually looks like. Schema-guided extraction is kind of like handing the AI a highly specific, totally non-negotiable checklist. Instead of asking the model to just, read and summarize the document, you're forcing it to act like a highly trained detective. It absolutely must retrieve exact, predefined fields from these complex visual layouts, making sure no critical data is missed or misinterpreted. All right, Section 1, Configuring the GPU environment, the training ground. Now, what's really interesting about this is normally a massive 9 billion parameter model just wouldn't fit on a standard, constrained 16 gigabyte GPU like an NVIDIA T4 or L4. But by using 4-bit NF4 quantization, which basically shrinks the model's memory footprint without losing its smarts, it fits perfectly. We also initialize an inference manager so the model stays loaded and ready for super fast batch processing.
Moving on to Section 2, Building the Synthetic Corpus, Creating the Antagonist.
Because we aren't just giving the model standard, easy documents here. No way. We're actively laying traps. We've filled these synthetic PDFs with deliberate distractors. We're introducing ambiguity between validation metrics and test metrics. We're purposefully burying the proposed model's performance right next to baseline model comparisons. We even planted edge cases where a code release is vaguely mentioned but entirely missing, along with some really tricky true or false state-of-the-art claims. How do you think an AI handles that level of confusion? Honestly, most fail instantly. And to make things even harder, we render these synthetic reports as multi-page PDFs using a library called Report Lab. We intentionally spread the crucial evidence across awkward page breaks and incredibly dense tables. We do this to mirror the absolute worst-case scenarios of real-world data mining. We want to prove for sure that Lyft is performing true vision and layout comprehension, not just doing a plain text keyword search. Which brings us to Section 3, Schema-guided PDF extraction, the battle for data. So the absolutely crucial point here is captured perfectly in just one phrase: schema in, valid JSON out. That's literally the core philosophy of Lyft. The vision model accepts your strict structural rules, looks at the chaotic document, and returns a perfectly formatted JSON object that respects your parameters entirely. Let's take a look at how this schema actually acts as the ultimate filter. We give Lyft some really explicit directives. We tell it, you must disambiguate the proposed method values from the baseline ones. You must differentiate test metrics from validation metrics. And you absolutely must distinguish actual release code URLs from cases where the authors explicitly state the code just isn't available. The schema guides the model safely right past all those distractors we planted earlier. Next up, Section 4, Scoring Against Ground Truth, the aftermath. And this brilliantly illustrates that our scoring pipeline doesn't just do, basic text matching. We use type-aware, field-level scoring. If Lyft extracts a numeric value, it's evaluated with a strict mathematical tolerance. Extracted strings are completely normalized before we compare them. Boolean values are handled explicitly as true or false. And crucially, if a value is missing or null, the system intelligently treats it as a purposeful abstention, not just an error.
Now we already know Lyft hit that amazing 90.2% accuracy, but let's be real, speed is just as important as accuracy in the real world. I mean, check this out. Lyft boasts an incredible median latency of just 9.5 seconds per document. When you compare that to legacy Azure systems lagging way behind at 73.7 seconds, the efficiency gains for batch processing are absolutely massive.
Finally, Section 5, Assembling the Knowledge Base. The data evolves.
Let's move to the results and see how this builds. Here we see the final, flawless transformation. Lyft cleanly maps all the fields. The authors, Sana Hassan et al., are perfectly extracted. The metric passes the mathematical tolerance check. The missing code link is correctly identified as a null abstention. And the state-of-the-art claim is accurately flagged as true. And here is where you see the real, practical power of this whole transformation. Because we've converted these incredibly dense PDFs into structured JSON, developers can now execute analytical queries instantly. Just imagine wanting to find every single paper in a massive library that claims to beat prior state-of-the-art models. Instead of manually reading hundreds of PDFs, you can pull that insight in milliseconds using simple database logic. The reason this matters so much for your own workflows is that this pipeline isn't just some cool demo. It's honestly a universal skeleton key for document processing. Whether you're building custom research corpora, analyzing incredibly dense regulatory and legal filings, processing complex technical reports, or dealing with literally any long-form document that requires high-precision extraction over generic summarization, Lyft is the tool for the job. We've seen exactly how to turn the antagonist of messy PDFs into beautifully structured data, and at record speeds too. So I want to leave you with this to think about. What hidden insights could you unlock right now by applying this powerful, schema-guided pipeline to your own custom document corpus? The tools are available, the model is proven. It is time to start extracting. Thanks for joining me for this explainer.